Welcome to my video lectures. This is Amarnath, Assistant Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology. Under the course Matrices and Calculus, these video lectures I am giving. Last lecture, we have done linear system of equations. Two types of linear system of equations. One is non-homogeneous, another one is homogeneous. Whereas we have completed the non-homogeneous system of equations, we have completed. That is, Ax is equal to b. The system of equation written in the form of Ax is equal to b. That we have done. Now in the present lecture, we are going to solve another system of equation, that is homogeneous system of equation. Ax is equal to 0. What type of solution exists? How many solutions are existing? Trivial, non-trivial, all types of solutions we discuss very clearly in this coming lecture. Now, so consider the homogeneous system of equations. What do you mean by the homogeneous system of equations? In the first order, that is a first degree linear system of equations where there is no constant. Completely look at this system equation 1. See, a11 x1, a12 x2 plus so on, a1n xn is equal to 0. Right hand side. Second equation also right hand side 0. But there is no constant part. Completely it involves the variables. No constants are involved. Such type of first degree linear system of equations is called homogeneous system of equations. So example, look at the example here. What do you mean by the homogeneous system? Suppose we have three variables x plus y plus z is equal to 0. So 2x minus y plus 3z is equal to 0. Right? X minus y minus z is equal to 0. See, clearly it is a homogeneous system. Homogeneous system. How can we say there is no constants are involved? All variables. In three variables x, y, z. So this type of systems we are going to solve. So this type of system to solve using matrix rank method, we need to convert this system into matrix form called Ax is equal to 0. Where A is called coefficient matrix. See, coefficients of x1, x2, x3, so on, xn in the first equation. A11, A12, so on, A1n. Second equation, A21, A22, A23, A2n. Next, last, so on, mth equation, AM1, AM3, so on, Am. It is an m cross n matrix. It is called a coefficient matrix. And x unknown matrix or variable matrix, x1, x2, so on, xn. And right side, O, there is a null column null matrix, 0, 0, 0, 0. So this system is called homogeneous system of equations. Ax is equal to 0. Now using the rank method, we need to solve this type of system of equations. So for this type of system of equations, look at it very clearly. If I substitute x is equal to 0, so 0 is equal to 0. So this system is solved. And x is equal to 0 means x1 is equal to 0, x2 is equal to 0, x3 is equal to 0. Complete all the values, x1 0, x2 0, so on, xn 0. All values are 0. This system is satisfied. Such type of solution we are calling as a trivial solution. Trivial means trivial solution, or we can call zero solution. Trivial solution or zero solution means each variable value is equal to 0. So look at this one. Example, what I have written here. Suppose if I write x is equal to 0, unknowns, y is equal to 0, z is equal to 0. So will it satisfy this equation? Directly will satisfy. So 0, 0, 0. 0 is equal to 0. 0 is equal to 0. But x is equal to 0, y is equal to 0, z is equal to 0. In three equations, all three equations are satisfied. Means not only this homogeneous system, for every homogeneous system, there will be at least one solution called trivial solution. That is 0, 0 solution. So here we have written. There is no question of no solution for homogeneous system of equation. Whereas for non-homogeneous system, solution may exist, may not exist. But at least one solution will be existing. At least one solution. That is trivial solution or zero solution. Why? Because zero solution will satisfy every homogeneous system. Put here any variable, all variables are equal to 0, automatically the RHS is 0. So here for the homogeneous system of equation is always consistent. Is always. So Ax is equal to 0 is always consistent. What do you mean by consistent? At least it has a one solution, at least one solution. Yes, we have one solution, trivial solution is there. That's why we can say every homogeneous system is always consistent. There is no question of inconsistent. Whereas in non-homogeneous system may be consistent, may not be consistent. It is always consistent. So that's why in the homogeneous system they don't ask find whether it is consistent or inconsistent. There is no question of inconsistent. Always consistent. Since every solution, every system, there will be at least one solution called trivial solution or zero solution. And a non-trivial solution, if at least one unknown value is not zero, at any value, xi not equal to 0 for any I, where any I belongs to n, at x1 or x2 x3, at least one value is non-zero, then the system is said to be non-trivial solution. Suppose if all i's are 0 for all I, xi is equal to 0, means x1 is 0, x2 is 0, x3 is 0, so on. All xn, all values are 0, that is trivial. At least one value not equal to 0, that is non-trivial solution. Then now we discuss when the system will be having, homogeneous system will be having trivial solution, when the system will be having non-trivial solution. That we discuss now. Now look at this one very clearly here. I have given the details, but briefly I can explain this one. So first of all, there will be a given system, that is a homogeneous system, Ax is equal to 0. So A is called the coefficient matrix, and n is called a number of unknowns. Number of unknowns. Suppose if I consider now first case, if rank of A is equal to number of unknowns, suppose you got rank 3 in the given system, unknowns also 3, or rank 4, unknowns also 4. So this situation is arising, then the system will be having unique solution as per our discussion in the non-homogeneous system. Unique means one and only one solution. For homogeneous solution, one and only one solution means that is trivial solution. So if rank is equal to, if rank of A is equal to n, then will be unique solution, that is called trivial solution. When it is, sir, if rank of A is equal to n, right? So this is the first one. The system will be having one and only one trivial solution. Second one, if that is nothing but briefly you can call R is equal to n. Suppose rank of A is less than n. Rank of A less than n. That is nothing but R is less than n case. So as per our non-homogeneous system, we have infinite number of solutions. Here also same thing, infinite number only, but we call that is non-trivial solutions. Non-trivial solutions. Non-trivial solutions, nothing but infinite number of solutions. And one more case here, compared to the non-homogeneous system, here suppose number of equations, is less than number of unknowns. What do you mean by that one, number of equations? Suppose we have given 2 equations, but unknowns are 3. Let us say consider one system, 2x plus 3y plus z is equal to some 0, and x plus y plus z is equal to 0. See how many equations are there here? Number of equations is 2 and unknowns are 3. In this case also, system will be having non-trivial solution. Why, sir? Here 3 unknowns are there, but equations are 2. So definitely number of equations are less than the number of required one. So one variable must be taken as arbitrary constant. Arbitrary constant means infinite number of solutions. Suppose I will take z is equal to as a k. K is an arbitrary constant. Arbitrary constant means we can give any value or we can assign any value to the k. So k is equal to 1, k is equal to 2, k is equal to 3. Like that, how many values we can give z? Infinite number of values. So how many solutions we get? Infinite number of solutions. That all are called non-trivial solution. So in this case also, we will be having non-trivial solution. Non-trivial solution. At a number of equations are less than number of unknowns, then now we will be having non-trivial solution. Next, last case, if the number of equations is number of variables at a 3 by 3, 3 unknowns, 3 variables, 4 unknowns, 4 variables, this is happening, and system has a trivial solution other than the trivial solution, that is non-trivial solution. Suppose the same system which we consider, let us have the one matrix method. So that is a 3 by 3, Ax is equal to 0, and coefficient matrix is 3 by 3. Unknowns also 3 by 3. We have x, y, z. Such system 3. So here number of equations is equal to number of unknowns, and system has a non-trivial solution. system has non-trivial solution. Whenever the system has a non-trivial solution, rank must be less than n. When it is possible, the det of the matrix must be 0. So that is remember the key point here. Rank is less than n means the determinant of the nth order matrix, must be equal to 0. Then only rank will become less than n. Rank is equal to n means det is not equal to 0, which has a determinant of order n. So, but R is less than non-trivial solution means R is less than non-trivial solution means the det must be 0. So, now the key point while doing the problems, this is an important key point. Whenever the system has a non-trivial solution and a number of equations is equal to number of variables, so key point to be remembered, det A must be 0. Now, remember the key points now. Rank of A is equal to number of unknowns, trivial solution. Suppose rank of A is less than number of unknowns, non-trivial solution. And the number of equations less than number of unknowns, non-trivial solution. Number of equations is equal to number of variables and non-trivial solution. Then det A must be 0. These are the key points while solving the homogeneous system of equations. Right? Means here just you need to find rank of A. Based on the rank of A, we can decide the solution. Then how to find infinite number of solution means there is a rule, n minus r rule for non-trivial solution. The difference between the rank and the unknowns, how much is there, that should be taken as the number of arbitrary constants. Number of arbitrary constants. How many should be taken? 2 or 3 or 4 or difference 1. One variable is arbitrary constant. Difference 2. 2 variables as arbitrary constant. In case of rank is less than n. How we have done in the non-homogeneous system, similarly here also we will do. Right? Now let us solve the one problem, which is a homogeneous system of equation. Look at the given system. See clearly first equation, second equation, third equation, 4 equations. We have 4 equations, unknowns also 4. All are equal to 0, no constant involved. This is clearly homogeneous system. Homogeneous system. Homogeneous system means, so it should be converted to Ax is equal to 0. Right? Let us solve the problem. Right? Given homogeneous system. Given homogeneous system. How will you write homogeneous system? In the matrix notation, Ax is equal to 0. Ax is equal to 0 means coefficient matrix, unknown matrix. Right? A is equal to, what you write, you know very well how to write the coefficients. Each equation, coefficients of x, y, z, w. So, first equation 1, 1, minus 2, 3. Second equation 1, minus 2, 1, minus 1. Third equation 4, 1, minus 5, 8. Fourth equation 5, minus 7, 2, minus 1. So, let us verify that one. 1, 1, minus 2, 3. 1, minus 2, 1, minus 1. 4, 1, minus 5, 8. 5, minus 7, 2, minus 1. And x means unknown matrix or variable matrix. X means here what are the unknowns are there? X, Y, Z, W. How many unknowns are there? X, Y, Z, W. 4 unknowns are there. That is 4. Now just we need to find the rank. What is the best method to find the rank of the matrix? Here that is we can find it the right. We can find the rank of the matrix using echelon form. So we reduce to echelon form. How to reduce echelon form? We know very well. Using the diagonal method, applying row operation, we can do below element 0. And using second diagonal element, we make below element 0. Using third diagonal element, we make 0. So like this, number of zeros are increasing. Such form is called echelon form. So we have discussed in earlier classes how to find the rank of the matrix. Now first one, using R1, make R2 element 0, R3 element 0, R4 element 0. Right. R2 implies R2 minus R1. R3 implies R3 element is 4. R3 minus 4R1. R4 implies R4 minus 5R1. So A is equivalent to first row 1, 1 minus 2, 3. Right? Second row R2 minus R1. 1 minus 1, 0. Minus 2 minus 1, minus 3. 1 plus 2, 3. Minus 1, minus 3, minus 4. Corresponding element subtract R2 minus R1. Next, R3 minus 4R1. 4 minus 4, 0. 1 minus 4, minus 3. Minus 5 plus 8. Minus 5 plus 8, 3. R3 minus 4R1. 8 minus 12. 8 minus 12, minus 4. Next, R4 minus 5R1. 5 minus R4 is 5. 5 into 1, 5. 5 minus 5, 0. Minus 7, minus 5, minus 12. 2 plus 10, 12. R4 minus 5R1. Minus 1, minus 15. That is minus 16. See, suppose third row you divide by 4. Minus 3, 3, minus 4. Clearly these three rows are identical. R2, R3, R4 identical means equal rows. Subtracting automatically becomes 0. 2 rows will become 0, 1 row will be left over. But we follow the routing procedure using a second diagonal element, that is should be non-zero. We will make below 2 elements 0. Right? Now R2, R3 implies R3 is minus 3, R2 also minus 3. So R3 minus R2. R4 implies R4 is 12. So this should be multiplied. R2 should be multiplied by 4. 4 R2. Then E is equivalent to first row we are using no change. Second row, so first row no change. Second row we are using no change. Third row R3 minus R2. 0 minus 0, 0 minus 3 plus 3, 0, 3 minus 3, 0, minus 4, minus of minus plus 0, minus 4 plus 4, 0. Next, R4 minus 4 R2, 0 minus 0, 0, minus 12, minus of minus plus 4 is a 12, minus 12 plus 12, 0, 12 minus 12, 0, minus 16 plus 16, 0. See, already we said the identical rows, definitely 2 rows will become 0, 3 rows are identical, and 2 rows will become 0. So, clearly it is in echelon form. It is in echelon form. How can we say it is in echelon form? Very clearly, zeros before the first non-zero entries, 1 0, here 4 zeros increasing. So how many 0 rows here? 2 0 rows. How many non-zero rows? 2. So what could be the rank of the matrix? Rank of the matrix is 2. That is in echelon form. We know very well number of non-zero rows will be considered as the rank of the matrix. Now here very clearly rank of the matrix is 2. R is equal to 2. Unknowns are 4. And R less than N. So as per our discussion, rank is less than N. Then what type of system it will be having? The system will be having non-trivial solution. R less than N, clearly system will be having. Right here I am writing. So it implies the system will have non-trivial solution. R is equal to N, trivial solution, unique solution, but non-trivial solution here, R less than N. So how many that will be non-trivial solution means how many solutions are existing means infinite non-zero solutions, infinite number of solutions. That will be non-trivial, which are not zero, right? So in this case we have a rule. What is the case rule? N minus R. Rank is 4. Sorry, unknowns are 4, rank is 2, the difference is 2. Means out of 4 variables, x, y, z, w, 4 variables, 2 variables will be selected as arbitrary constant. Generally, last 2 variables we select. So, let z is equal to k1, w is equal to k2 be the arbitrary constants. Arbitrary constants. Arbitrary constants means we are fixing z value and w value as arbitrary. Arbitrary means it can take any value. K1 is equal to 0, K2 is equal to 0, like that you can take any value. So that is the meaning. And you need to find x and y in terms of K1, K2. That will be our non-trivial solution. So again, how to find the solution means we used to take Ax is equal to 0. Ax is equal to 0 means this matrix. This is a matrix, this is a X matrix. So here A matrix 1, 1, minus 2, 3, 0, minus 3, 3, minus 4. 0, 0, 0, 0. After the transformation, whatever we got, that E should be taken. Not the initial matrix. X. X means unknowns. X, Y, Z. Z means you can write K1. W means you can write K2. So is equal to what, sir? Is equal to 0, 0, 0. Now we need to solve for X and Y. So multiply first row with this row with the column. We know the multiplications. 1 into X. 1 into y, minus 2 into k1, minus 2 k1, plus 3 into k2 is equal to 0. So again, take the second equation. Second equation is 0 into x, minus 3 into y, means we are multiplying second row with xy, xy, k1, k2. 3k1, next minus 4k2 is equal to 0. Right? Here we have clearly, one second. So this is here we can have the matrix. So second row 0 into x minus 3 into y plus 3 into k1 minus 4k2 is equal to 0. So from this equation directly we can write the what is the y we can write. So minus 3y is equal to, so here I am writing minus 3y. We need to find y from this one. If you take the other side, that is so here I will write. So this is the first equation. This is second equation. From equation 2, minus 3y is equal to, take to other side, that is minus 3k1 plus 4k2, which we need to solve for y. So y means divide by minus 3. Minus 3 means k1 minus 4 by 3 k2. So dividing both sides with minus, both sides minus 3. Substitute in the equation 1, right? So x we need to find, right? So x plus y. Y means just now we obtained k1 minus 4 by 3 k2. So minus 2k1 plus 3k2 is equal to 0. So we need to solve for x. So add the k1 terms. So here k1, that is minus k1. K plus k1 minus 2k1. Next minus 4 by 3 plus 3. So here we have minus 4 by 3 k2 plus 3k2. So if you take LCM, 3 minus 4, 3 3 is a 9. 9 minus 4, that is 5 by 3 k2. So plus 5 by 3 k2, which is equal to 0. So now I want x value. Transpose to other side, k1 minus 5 by 3 k2. This is x value. So here already we have y value. Here z value, w. That all together we call our solution. That is x comma y comma x comma solution. What is the solution means? X, y, z, w. That all values we have, you can write. That could be our solution of this homogeneous system of equations, which are non-trivial. How can you say non-trivial, sir? You give k1 is equal to some value, you will get x, y. K1 is equal to some 0. Let us take k2 is equal to 1. If substitute here x, y, z, we will get one solution. You take one more combination, x1 is equal to, x2 is equal to 3, minus 1, minus 2. Different values of k1, k2 will generate different solutions. How many like that we can generate? Since k1, k2 are arbitrary, we can generate infinite number of solutions for the given system. This is a very, very important case, right? So we'll go for next problem. See again, one more homogeneous system of equations. See, look at the equations. First equation, second equation, third equation completely 0 and no constants are involved. That is called homogeneous system of equations. So given homogeneous system of equation, how to solve means, we will first of all we will convert to matrix representation. Ax is equal to 0, where A is called coefficient matrix. What is A, sir, here? 1, 1, minus 3, 2. Means first equation x, y, z coefficients. Second equation 2, minus 1, 2, minus 3. 3, minus 2, 1, minus 4. Minus 4, 1, minus 3, 1. X means unknowns. What are the unknowns here? 4 unknowns are there. X, y, z, x, y, z, w. How many unknowns here? 1, 2, 3, 4. 4 we have. So once again look at the equation 1, 1, minus 3, 2. Second equation 2, minus 1, 2, minus 3. Third equation 3, minus 2, 1, minus 4. Fourth equation minus 4, 1, minus 3, 1. This is our coefficient matrix. So what we'll do? Reduce to echelon form. So reducing to echelon form. So how we answer the homogeneous system? Using the rank method. And we need to find the rank of the coefficient matrix A using echelon form. So how we'll do? Explain in the previous problem, that is using diagonal elements, make the below elements 0, apply only row operations. So using R1, make R2 element 0, R3 element 0, R4 element 0. That is R2 implies R2 minus 2R1. R3 implies R3 minus 3R1. R4 implies R4 plus 4R1 because opposite sign minus 4 means plus 4. So this is A is equivalent to first row 1 1 minus 3 2 1 1 minus 3 2. Second row R2 minus R1. So R2 minus 2R1. 2 minus 2 0 minus 1 minus 2 minus 3 2 plus 6. So because 2 minus of minus 2 plus 6 8 minus 3 minus 4 and minus 7. R2 minus 2R1. 2 minus 2 0 minus 1 minus 2 minus 3 2 plus 6 8 minus 3 minus 4 minus 7. R3 minus 3R1. The 3 minus 3 into 1 3 3 minus 3 0 minus 2 minus 3 and minus 5. 1 minus of minus 9 1 plus 9 10 minus 4 and minus 6 minus 10. Okay, minus 4 minus 6 minus 10. Next R4 plus 4R1. R4 is minus 4 multiplied by 1 4R1. 4 plus 4. So minus 4 plus 4 0. 1 plus 4 5. Minus 3 minus 12. Minus 3 minus 12 minus 15. Minus 3 and minus 12. 4 to the 12. Next 1 plus 4 to the 8. 1 plus 8 9. Now first step completed. Using first diagonal element, first row we have done below element 0. Now we will come for second diagonal element. Using second diagonal element, we will make below elements 0. After using R2, we have to make R3 element 0, R4 element 0. That is cross multiply. Since 3 and 4, 3 and 5 no common factors, cross multiply. That is R3. R3 we are making 0. R3 implies 3 into R3. 3 5 is 15. Minus 5 into R2. 5 is 15. 0. Next R4. Same thing. 3 into R4. 3 5 is 15. So opposite signs are there. Plus 5 into minus 3. That is 5 into R2. So 3 R4 to 5, 3 5 is 15. 5 into minus 3 plus 15. Minus 15 plus 15 0. Next. Now using the first second row we are using. The first row, second row, no changes. 1, 1, minus 3, 2. So 0, minus 3, 8, minus 7. Right? 3 R3. 3 into 0, 0 minus 0. 3 into R3, minus 15, plus 15, 0. 3 into 10, 30. 30 minus 5 into 8, 40. 30 minus 40, minus 10. Next, 3 R3, minus 30. 3 R3, minus 30. Minus of minus plus 35. Minus 30 plus 35, that is plus 5. Right? Do some rough work and get the simplification. Right? Next, 3R4 plus 5R2, 0 plus 0, 0. 3R4, 3 into 5, 15 and minus 15 plus 15, 0. 3 into R4 at 15, 5 into minus 3 plus 15, 0. 3R4, 3 into minus 15, minus 45 plus 5 into R2, 5 into 8, 40. Minus 45 plus 40, that is minus 5. 3R4, 3 into 9, 27. Minus 5 into 7, 35. 27 minus 35, that is minus 8. Right? So here we have the second row diagonal. This task also completed. We'll come for the third diagonal element and we'll make below element 0. After using R3, we have to make R4 0. Okay. Now, R4 implies R4 is minus 5 and multiply by 2 R4. So minus 2R4 minus R3. 2R4 at minus 10 plus 10 0. Now this is A is equivalent to first 3 rows. No change. Write down as it is 0 0 minus 3 8 minus 7 0 0 right second 0 0 minus 10 5. Now apply the operation 2R4 minus R3. 0 0 2R4 means 2 into minus 5 minus 10 and minus of minus plus 10, that is 0. Next last element 2R4, 2 into R4 and minus 16 minus R3 and plus 7. So 3 plus 6, that is minus 9. Okay, na? So 2R4, 2 into minus 8 minus 16 minus of minus plus 7, that is 3 minus 9. Now say clearly 1 zeros, 2 zeros, 3 zeros. clearly satisfying the condition of echelon form. So it is in echelon form. So finally, the reduced matrix, what we have done here, that is in echelon form. In echelon form, what is the rank of the matrix? Number of non-zero rows. 1, 2, 3, no 0 rows here. Completely non-zero. One element is non-zero, that is non-zero. Rank of A is equal to 4. So, but how many unknowns? Unknown is also 4. What is the case here? R is equal to n. First case. Rank is equal to number of unknowns. Then system will be having 0 solution, which is called trivial solution or unique solution. Whatever you say, that's same. Unique solution, trivial solution or 0 solution. Means all variables are equal to 0, 0, 0. That is x, y, z, w. Trivial means 0. X is 0, y is 0, z is 0, w is equal to 0. No other solution will be existing as per the rank properties. So this is the solution of this system. Right. So in this session, clearly we have discussed about the solution of homogeneous system through the two problems and conditions. What is trivial solution? What is non-trivial solution? These all we discuss very clearly. In coming problems, we do some more problems on this homogeneous system of equation where some unknowns are involved like lambda, mu, k. So this type of parameters will be involved and he will be asking to find the values so that system will be having non-trivial solution. This type of models we will do in the coming lecture. Right. Thank you.